Oh, hi again, welcome back. We've got one of these to fix today. This is a CW3000. What that means I don't know. I think it probably means the 3 litre, but this is an industrial chiller for a laser cutter. I run laser cutters at work, and this is probably one of the most reliable pieces of equipment I've got. I think I've got 5 of these, six of them I think, and this is the first one that's gone wrong in 10 years. So I have to say that's pretty damn reliable for a piece of equipment that's in use nearly every day. So let's just take the lid off and we'll have a look and see what's in it, and I'll show you. I've had 1 or 2 of these apart in the past, mainly to clean them, but I took the screws out on the sly off camera. So this is what's inside. 2 cooling coils, a fan. Don't know if you can see that, but there's a mains fan at the end there. Power comes in, goes through a power supply, a big tank. I think that must be the 3 litres, although it looks more like it's got to be 5 or 6 litres. A pump, a power supply, and that's about it really. So let me I'll spin around so you can see the pump. Right, there's the pump. I always thought when I first bought these years ago that this was going to be the thing that fails, but I have to say this particular one is, I think this one is about 5 or 6 years old, and it seems to be absolutely fine. There's a little bit of control electronics in it. Woohoo! I don't know if you can see that very well, but there's a temperature meter and an alarm, and just that toggles either way. So yeah, I'll show you some close-ups of some of the bits in it. On the back we have an inlet and an outlet for the water. The inlet comes back in from whatever laser cutter has been working through, goes through a little T-piece, a Y-piece, into both of these coils, these cooling coils. From there it goes down to the bottom, and it's pretty difficult to see, but there we go, there's the return. So the return goes into the bottom of the tank, and then it filters its way through the tank and sits there. And the other side we have the pump that takes the water out, pumps it back up again, straight out through, and it goes through this piece of kit here, which is a flow sensor. Right, this flow sensor just basically operates when there's water flowing through these tubes. So if something goes wrong and it stops pumping water, the pump fails, the power supply fails, or whatever, it then causes an alarm, and it sends a control signal, whoops, out of the back here. Basically it's just a relay. These 3 contacts are common, normally open, normally closed, from a relay that is really difficult to see. There we go. Right, buried in the front of the machine is the relay, along with the temperature module and some sensors. Again, that's really difficult for me to get you in there. There we go. There's a couple of switches, thermally operated switches that are bonded to the side of the tank. They provide the control signal for an over temperature alarm, and the actual temperature is monitored by this little sensor here. I think it's just a thermistor that's buried in the bottom of the tank. So it's a really simple bit of kit. The only recommendations that I'd give you is use cooled boiled water in here, so that if you're in a hard water area like we are here in Norfolk in England, you can fur these things up a little bit in time. It'd take years, but you could do so. That's always a good idea. Also, having effectively water that doesn't contain any chalk means that you're not going to be pumping any bits through your pump, because that's probably a weak point, the impeller in there. So yeah, there we go. My guess is this particular unit has a power supply issue, because there's no lights on the front at all, if I remember rightly, and it does seem to pump. Sorry, it doesn't seem to pump. So that leads me to believe there's no power coming. There's no power coming to the pump. Before I do anything, I'm going to take this outside and drain it. Fault finding. First thing to do is to actually verify that the unit is dead. So let's plug it in. We've got an alarm condition. That's fine and dandy. No display. Pump's not running. Yeah, so it's partially working. Okay, now we can find out what's gone wrong. My feeling is, I'm fairly sure that there's a little power supply in here. I think that's gone toast. But so clearly the fuse is working. In the there's a fuse in this inlet. So next thing would be for me to actually disconnect that, because I'm going to do some chopping of some cable ties. I'll just release this wiring harness a bit so that we can get a multimeter on these connections. Let's just break those apart, which ones we need to get at, and then we'll have a bit more of an examine. These are the two connections I'm looking at. So this is hopefully the 24 volts out of the power supply. Let's turn it on and see. There is a small voltage measurement there. Pretty much nothing. Yeah, this power supply I think is toast. So if I chop through the cables feeding it and coming off it, I can reuse those wires. There we go. In a bucket of broken dreams with that. Right, I don't have a suitable wall wart supply, but I do have one of these. It's an old industrial switch mode supply, more than capable of supplying the power that we need. This is 24 volts at 1.2 amps, more than enough. This is 25 watts at 24 volts, that's about 1 amp. So we're there. We'll go there. There. Right, let's put some power in. I think the alarm is still going to go off, but we should, when I turn it on, see lights there. There we go. We've got lights. That's good. The pump is running. And we have a temperature indication. Powered up. I put 3/4 of a tank of water in it. Let's see if it pumps. Well, hey! Man, I wish I could weed that hard. That's gone all over the workshop. Marvellous. Well, that worked. I've checked there's no leaks. I'll just put a couple more tie wraps back in here just to tie it all up. Not going to bother sealing those, they're all right. And put the lid on. So just let me get on with that. Right folks, there we go, how to fix an industrial chiller from a laser cutter. So I've got a few of these, and like I said, this is one of the most reliable pieces of equipment I've got. Laser cutters, on the other hand, are a piece of rubbish. I could use stronger terms. The only thing that I would change, if the manufacturer is ever listening, the only thing that would be really good, they do a 5000, which is a slightly bigger machine, with a gauge on it, so you can see how much water is in it. That would be damn useful for these, because the pipework inside is neoprene, and neoprene allows water to escape. It just seeps out through the sidewalls, I think. So over a period of time, the water that's going around in here gets lower and lower and lower and lower, and it's only when you raise an alarm that you realise that actually you're getting low on water, or the temperature is so damned hot that you think, I'm going to break something here if I carry on. So anyway, thanks for watching. Do hit the bell and subscribe banner, and we'll see you on the next one. Take care. Incidentally, just for completeness, I will say I forgot to bring a piece of neoprene tubing to link the input and the output on the water side of it, but I will run this for an hour or so just to make sure that it's the power supply, because the power supply is donkey's years old, is going to hold out for the time being. So I will soak test it. Soak test it? Is that the right thing? Anyway, ta-da.